So when you look at all these curves here, these are what I call the four basic pieces. What are the four basic pieces right here? The four basic pieces are this. Let me write this. This piece right here. This piece, and this piece, and then this piece, and then these pieces. This piece right here. These are what I call the four basic pieces. If you look at any curve, again, if you look at any curve, every curve, basically, it can be cut down into one of these four pieces. Okay? So let's say if you think of a circle, and now you know what? Here, let me just graph a circle. How big if I just graph a circle like this? You know what? Let me just graph. Then, so this is a circle right here. The circle kind of looks like this. Now, if you look at the circle here, then the basic four pieces are referring to the four parts of the circle. The four parts are basically the four quarters. So what are the four quarters here? The four quarters are over here. Is this part right here? So let me write this. Okay, so is this part? Oops. You know what? Let me make it different. This part right here, the curve looks like this piece, or this piece, or it's going to be this piece, or it's going to be this piece. Then the curve looks like this. You know what, let me do this one. If the curve looks like this, then from here, to here, like this. Now, it doesn't matter how the pieces look like, whether they are discontinuous or not continuous, or differentiable, not differentiable. But in this case, you can go from here to here, and then from here to here, and then from here to here somewhere. I'll talk about that. And then from here to here, and then from here to here.
Okay,
and then from here to here,
really batten down
and
the
then you can call this
hatches.
guy open. Then from here to here, and then from there to there, and then to there, and then to there. So this big piece, this big curve right here, this curve I've drawn right here, this black curve, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It actually can be broken down into 10 pieces, where every piece is going to be one of these shapes, except for straight line. If it's a straight line, it doesn't belong here. But you know what? We are studying calculus because we are dealing with curves. A straight line with line segments are easy. Okay, so line segments we don't divide. But if any part of the curve is not a line segment, then it consists of any one of these four pieces. So I call them four pieces. The four basic pieces, so I call them four pieces. These are the four basic pieces. Okay.
Professor, I have a question about the concavity.
Yeah.
Oh, there could be a function that's concaving up but still be decreasing, right?
That's right, and I'll talk about that.
Okay, awesome.
Now, if you look at, in fact, maybe I'll answer your question first. Now, if you look at, I number the pieces, number 1, 2, 3, 4. You see that? The four basic pieces. For this one, I just sort of number them. Number 1, 2, 3, 4. Okay. Now, these pieces, they don't have any numbers, but for convenience, I just number them. So number 1, 2, 3, 4. Now you mentioned, did you say that f is increasing and f prime is decreasing? Which one did you mention?
I was just saying in general, if something is concaving up, it can also be decreasing.
Right. Concave up. If you look at number 1 here, now let's look at f. Let's see whether f is increasing or decreasing. For number 1, f is increasing. And then number 2, f is what? Number 2, f is, so you know what, let me do this. For number 1, f is increasing. So piece number 1, f is increasing. The function is actually going up. And then number 2 and number 3, function is decreasing. F is decreasing, and then this f is decreasing. So that's number 3, number 2 and number 3. And then number 4, f is increasing again. Now let's look at f prime. If you look at number one curve, note that f prime is decreasing. What does it mean by f is decreasing? So if you look at the so-called tangent lines here and here and there, you can see what is this here? The slope of the tangent line is actually decreasing. It's like 5 and the 4, 3, 2, and then now it's 1.5. So if you look at number 1, f is increasing, but f prime is actually decreasing. That's number 1 piece. Now let's look at number 2 piece. Number 2 piece, f is decreasing, but f prime is also decreasing. So when f is decreasing and f prime is decreasing, then that means it's like piece number 2. And if you look at number 3, f is decreasing, but then f prime is increasing. Why is that? I'm going to show you this on my graphing calculator, a graphing website. And so 3, f is decreasing, f prime is increasing. And then now what is this f here? And number 4 piece. In this case, that's easy. Number 4 piece is the easiest. F is increasing, f prime is also increasing. And by the way, do not distinguish the fact that 2 segments, f is increasing. It is not the same as saying f is positive. F is positive. They are not the same thing. So the second statement here, this f is greater to 0. This is how we say this. This right here, we say f is positive. But f is positive is not the same as f is increasing. So do not get these things mixed up here. This is f is increasing, and f is positive is not the same thing. So when you say that f prime is increasing, that means f prime is increasing. It is not the same as saying f prime is positive. That's the different thing. All right? So these are the 4 basic pieces. Now I'm going to reinforce this. So what I'm going to do is, don't get everything, don't worry. I still have some time to spend here. So what about this? And let me now go to the graphing website and then see how things work. And now here is this. Oh, by the way, you know what? This is now going back to the quiz. And then to some of you actually, drew through this quiz. You answer it, and then you get a graph like this. Now, this function right here, is that an increasing function? Or from 0 to infinity? If you just look at the point from 0 to back here, I'm actually going back to our quiz 6. All right, quiz 6. This is the graph, and then this is increasing. So when you look at the graph here, is the function increasing? Does it look like the function is increasing? But let me show you the trick here. If we magnify this here, you know what? This guy's not increasing. Look at that. It looks like it's increasing, but if it's going up and down, it's not increasing at all. It's going up and down. When it goes up, it's increasing. When it comes down, it's decreasing. But what I'm trying to show is that when you look at this graph here, you cannot be sure. This is what I'm trying to show. And this is the reason why you cannot prove anything by what? By graphs. Understand? And you know what the equation is here? I've written down right here. And the graph is number 9. I added this thing here. 1/300 times sine of 200x. If you read this function, you magnify it so many times. You know what? No matter how much we magnify, it's going to be very hard to see how much. You have to memorize quite a bit. You know, to see that this guy is increasing. So you know what, if you just magnify a little bit, now we begin to see what's going on. But now it's still increasing. It's still increasing. See? It's still increasing. But is it ever decreasing? No, we don't see that. If you want to see that this guy's actually decreasing, you have to actually go up quite a bit. Wait, does it really increase or decrease? Well, you know what? Well, my thing is basically what I'm trying to say is that we don't know. So if we change that to 3,000, actually this might be an increased function. But definitely if I make it 300, yes, then this is what? This is not an increasing function. So this is the reason why you should not approve it. Now what I'd like to do, now let's get to this right here. Let me now click our graph. Our graph is this. Where's the graph? Oh, there's a graph. Oh, there's a graph right there. Now let me now click this guy here, number 4. Oh, there you go. And let me also click this one right here. Let's click this one. And let me click that one. And then here we have this. And so now let me magnify this part right here. So let me let me clear this. Erase everything. Okay, so now we have this. So now what we have is Let me magnify this part a little bit. Not too big. So this right here, and now what you see, this is what you see. See the part right here? This is tangent line. So now this part right here, okay, so now what I'm going to do is, let me mark some points. Let me mark some points here, annotate. And so let me mark some points. Let me mark this guy. Oops. So let me mark the point right here. And then now let me mark the point over here somewhere. And then let me mark the point here. And then we have this. This graph right here, so this graph, the exact equation is this guy right here, which I typed in right here, number one equation. And, oops. Oh, there you go. If you have this here, if I mark the 3 points here, and now this curve is divided into how many pieces? This curve is now divided into, is chopped into 4 pieces. So maybe I'll annotate. I can call this guy number 1. And I can call this guy number 2. And then this guy right here is number 3. And this guy is number 4. And so it will fit that pattern. So now let's look at piece number 1. Piece number 1, what is it? So on piece number 1, what is it here? This is piece number 1. You can see, f is increasing because the derivative is positive. And second, f prime is decreasing. If you see this part, what do you see? F prime is decreasing. You see the slope here? The slope is actually decreasing. So on number 1 curve, let me write it down. On the first part, on part 1, what is it? Let me write over here on part 1. On the curve, part 1. On part 1, what do we see? We see that f is what? F is increasing. And then what is it? F prime is what? F prime is decreasing. So that's what happens to part 1. Everybody see that? Now if you look at the second part 2, what is this part 2? Part 2 here, we are with it. Now part 2 here, definitely f is decreasing. F is decreasing, but then is f prime increasing or decreasing? F prime is what? From part 2. Is f prime increasing or decreasing? From here, f prime is actually decreasing. See, it's negative, more negative, it's actually decreasing. And then we come to a point like this somewhere here, right here. And that point right there is what we call, I'll talk about that inflection point a little bit later. Yeah? But anyway, that is the inflection point. And this is the point where we actually make a turn. Now, when you go to part 3, the third piece is now this. F is decreasing and f prime is increasing. F is decreasing, obviously. The function, the graph is going down. F is decreasing. But then f prime is increasing. Why is that? Because f prime is, let's say, minus 5, then minus 4, minus 3, minus 2. You know, I can show you, you know what, we have this part here, and then, and then this part here, number 4, f is increasing, and f is increasing, and f prime is also increasing. So if I, let's say, if I now look at this,
are you serious?
It will show I am. So let me click the M here. All the pieces, let me see. Can I fit it in here?
Joyce, you
Where
better be fucking telling the truth. You could die. What are you talking about?
Is it magnified? When I do that, is it magnified? Oh yeah, it is magnified. I see. Okay, you know what? I cannot scale this again. So anyway, I'm just going to erase all this. Here. Alright? So now I can show you, let me click number M. M is the slope of the tangent line. Oops. How can I not? Why? Okay, annotate. No, not annotate. I don't want to annotate. So I want to click this guy. Wait a minute. How can I click this guy? I want to click this one. I should click this one here. M. Oh yeah, and you know what? Oh, sorry. Number 2, I was trying to click this, but I realized that number 2, there's nothing to click. Okay, so that's my mistake. Number 2 is the slope of the tangent line. And as you can see, if we go on, let's say this part right here, from here to here, see, look at the end there, m is actually increasing. As you go from left to right, it's actually increasing. And then if you now go to the other part, it's now increasing. So f prime is increasing and f is increasing on this part. So that's what it is. Okay, so that's that. Now if I set the normal line, yeah, I'll show you. Let me see, where's the normal line? Normal line is over here. That is my normal line right there. If you put the normal line, you can see this. You get a nice picture like this. So the black line is the tangent line, and then the purple line is the normal line. Okay? Is that nice? Yeah, it's been, yeah, I stopped there because I said that that's a only area of the three. So it stopped there, but anyway, basically that's the tangent line is the normal line. Okay, so far so good. So now what I'm going to do is I'm going to now go back to the file. And now what I'm going to do is I'm going to let me now do this one here. Now 4 pieces number 2, let's look at this guy. And we now have this. So now the 4 pieces, I've written it this way. So what are the 4 pieces? The 4 pieces are, once again, this piece right here. And we have this piece right here. And we have this piece right here. And we have this piece right here. So you have to know the 4 basic pieces. Again, every curve.
It's too late, Joyce. This is
we will be able to cut it into these pieces, where every piece is one of the 4 pieces. And of course, 4 pieces are written down right here as well. This is the piece 1, and this is the piece, the piece, and then this piece, and that piece. Yeah. How do you memorize it? It's like a circle. A circle, the 4 parts of the circle, the 4 quarters of the circle, the 4 pieces of this. So you can now chop it up. Chop it up, what is it? Chop it up into 4 pieces like that. You can chop it up like this. And then every quadrant is like a piece. See, like that. Okay, so if you come back to the 4 pieces here, the first piece, this piece right here.
There are people who can't get that.
What is this? Am I sharing the page? Oh, there you go. So this piece right here. So this piece right here. This piece is what? This is the case where f function is decreasing, but f prime is increasing. And this is the piece where f is what? This is the second piece at the bottom right here. The function is increasing, but f prime is decreasing. The slope is actually getting smaller. And then the third piece over here, f is decreasing, and f prime is decreasing. Because the derivative, that is the slope of the tangent line, is actually decreasing. It's becoming more and more negative. And then it's this. So basically, if you look at, if the curve is either this piece or that piece, this is the case. These 2 cases are the cases where.
Shut up! You
where
could
f
kill
prime
her.
Is what? F prime is what? F prime is decreasing. So these are the 2 cases where f prime is what? Is decreasing. And f prime is decreasing. What does that mean? That means that's the same thing as saying f double prime is what? F double prime is a negative. So these two curve pieces right here, f prime is decreasing, and for these 2 pieces, f double prime is less than 0. That means f double prime is negative. That's the right there. Okay? So if it's open down, then that means that it's concave down. So concave up means it's opened up. Opened up means these 2 pieces right here. So if you look at the top here, curve number 1, 2, 3, 4, the number 3 and the 4, these are the 2 cases where it's opened up, concave up. And that means f double prime is positive. It also means that f prime is increasing. So when f is differentiable twice, then f prime is increasing and f double prime is positive. They mean exactly the same thing. Note that increasing and positive are not the same term. So for curve number 3 and 4, f prime is increasing, or n, f double prime is positive. If f double prime is positive, then f prime is increasing. Does that make sense? They mean the same thing. Same thing. If f prime, sometimes we say this. When you say f prime is increasing, when f is increasing, f is increasing, that's the same thing as saying f prime is what? F prime is positive. So these also mean the same thing. Sometimes we say f is increasing, or sometimes we say f prime is positive if the function is differentiable. But sometimes the function is not differentiable. In that case, they're not the same. But if the function is differentiable, then that means these two, they mean exactly the same thing. So here, let me write here. So what is this here? Draw. Yeah, so this right here and this right here, they mean the same thing. Because, yeah, that if it's differentiable. Okay, so now let me go back here. Let's see, go back. So you know what? Let me go back to this clear. What is it? Clear. What is this here? Clear all the drawings here. Okay, I'll just clear. Undo. Let me save this, and then I'll clear everything. Now let me go to the last file here, the concavity file. Oops, concavity file. Where is it? It's over here. This one. Let me erase everything. So now let's look at this. Now what is the easiest way to understand concavity? Concavity, so here we see a curve here, and that's the curve right there. And here, let's say we have a car. If you see this car right here, we have a nice car. And what we are going to do is we are going to drive along the car. Let's say we are on the car, and we are on the curve. We are in the car, when you're on the curve, we are going to drive along the curve. Okay, along the curve. Now, as we go from here to here, what happens here? From here to here, go this way. Are we making a right turn or a left turn? Is the steering wheel turn to the right or steering wheel turn to the left? What do you think? Is the steering wheel turn to the right or turn to the left? It's turned to the right. Because when you compare the tangent line, the curve is actually to the right. So we are actually making a right turn. As long as you're making a right turn, now we are driving from left to right, of course, on the curve. As long as you're making a right turn, this is called concave down. And then we come to a point here. Now the steering wheel is now going straight. So at this point, we are instantaneously going straight. And then from this curve right here, as we go this part right here, so now let me change it to green. Now as we move on this curve here, now it's a green arrow, as we drive along this curve, what happens here? We are now moving to the left. We are making a left turn. So if you're driving along the curve and you're making a right turn, that means it is concave down. Oops. Let me change this in blue, in black. This is now concave down. But then if you're now making a left turn, that means it is now what? It is now concave up. That's the easiest way to see it. So let's look at this one more time. Let me erase all this. Okay, all right. So let me erase all this, clear all this, and then after you go to the left side again, as you can see, what is this here? Okay, so let me erase the normal line. So here, let's if you drive this, we are making right turn. So if you're along, if you think that our dog is our car, and we are driving along this one, then it will still make a right turn, and then still make a right turn, and then make a right turn, and then
I'm saying
here, and then from here somewhere we start making left.
I'm saying.
So now, once again, what do we see? You have to see a point here somewhere. And that point is the point where we are changing from right turn to left turn. And so when it says right turn, it's actually concave down. That means F double prime is what? F double prime is negative. That's the same as saying F prime is what? F prime is what? Is decreasing. That's this part. And now, the other part here, what happens here? We are now making a left turn. Left turn. And if it's a left turn, what is it? And that means the F double prime is positive, and F prime is increasing.
No,
any question on this?
I said stop it. You've already attacked me twice.
So you have to know these four pieces really well.
It didn't mean stop with all that
That's why I spend so much time here. Make sense?
You don't have to say that.
Questions here? Anybody have any questions? Okay. Then I'm going to clear this. Let's go back to the slide. So now let me go back to this thing, 0.32 again. So that's where we are. We're back to the section 3.2 original file. And so I want you to know these pieces. I want you to know this really well. If f prime is positive, then what? Then f is increasing. If now let me ask you this. Now let me ask you this. If f is increasing, then f prime positive. Do you think this is correct? What do you think? If f is increasing, can we conclude that f prime is positive? Can you say that? What do you think?
No.
If f is increasing, can you say that f prime positive? What do you think? Or f? How about maybe I should write f prime is what? Is positive or 0? Let me put it this way. Oh, what color is this? I see. Well, this is red. Okay. This is red. Let me do this, and so we have this one here. Okay. So let me do this again. So do you think this is correct? If f is increasing, can we conclude that f prime is positive or 0? Yes or no? This is true or not? Now, when you get to curve sketching, we need to know this. We know that if f prime is if f prime is positive, then we know that f is increasing. But how about the what is it? It's called the converse. I think this is called the converse. I think. If f is increasing, can you conclude that f prime is positive? What do you think? Can you say that or not? Time is ticking. Is it correct or incorrect? The answer is no. Now let me write the correct statement. If f is increasing and f is what? F is what? F is differentiable. Then f prime is what? Then f prime is what? Is positive. This is correct. So if f is increasing and f is differentiable, then f prime is positive. So now let me say this again. How about this? If what? If f is increasing, and what? Then what? Then what can you conclude then? Then either then what? F prime is positive, or f prime does not exist. This is no, false. This one is true. The second statement is true. And the last statement of the line is also true too. Okay, so the first statement is false. If f is increasing, then f prime is positive? No, that is false. What is true is if f is increasing and f is differentiable, then f prime is greater than 0, and that is true. If f is differentiable. F is differentiable, same thing as saying f prime exists. Same thing as this. So if f is increasing and f prime exists, then f prime is positive. Then f prime is greater than 0, and that is true. Or the other way is saying it, if f is increasing, then either f prime is positive or f prime doesn't exist. That is true. So I want you to know these statements really well. Now I want you to understand the logic here. All right? Any questions here? Any questions? If you have no questions, then now let's get to some problems. Now, you know what? Finding the derivative and the second derivative of all of these functions is very time-consuming here. So last night, I stayed up. I stayed up very late, and then I actually took the derivative, and typed it in. So now I'm trying to save some time here. So what I'm going to do is I'm going to save this and then clear this. And now what I'm going to do is I'm going to open up the other file and call the section 0733 first and second derivative. And this one is the same file, except this one I wrote down all the derivatives and second derivatives here. So this is now the file. Yeah, as you can see, I've written down all the derivatives and the second derivative, all the functions. That's what I did, okay? So now, let's look at this. Now, should I, okay, so here we have a curve, f of x. And now, we want to graph this. How do you graph this? In order to graph it, what do you need to do? This is what we have to do. So, to graph these functions, okay, so to graph, what do you need to do? To sketch the equations, manually. Must find what? Well, must find f prime and f double prime. And factor and what? In factor form and what is find that and right, and then what? And then factor and analyze sign. And then we'll be able to sketch the curve. Okay? So we start with polynomials. Polynomials are by far the easiest. So this is what we do. So let's look at example 1 here. So example 1, so let's see what we have here. Example 1. Where is it? Annotate. Okay. So example 1 here, and so this is the curve right here. F of x is equal to what? F of x is equal to x cubed minus 6x squared. X cubed minus 6x squared. And so this one here, if you factor this, we actually get this guy right here. And at this point, we can actually write the zeros. What are the zeros here? The zeros are what? The zeros are, what is it here? So let me write down the zeros. The zeros are 0, 0. So we can see that the zeros are 0, 0. And the other 0 is 6, 0. Okay? So those are the zeros. 0, or we can actually call them x-intercepts. Actually, the proper thing is to say x-intercepts is the proper one. The exponent of the x-intercept, they are called the zeros. X-intercepts, 0, 0, and y 6, 0. And the origin is also the y-intercept. That's what it is. Now, in order to sketch this curve, what do you do? We have to what? We have to find the derivative. So when you find the derivative, you get this. So when it comes to curve sketching, you have to convert it to this form right here. And this is the factor form. We need to have the y, f prime, the derivative and the second derivative, both in factor form. Why? Because we have to analyze the sign. And then now we take the second derivative, you get 6x minus 12, and that is 6 times x minus 2. Again, we need that in factor form. And so the first step is to find the first and the second derivative. That is the first step. And now the second step is now create a chart. Now what? Okay, so now what is it here? The curve sketching procedure. Curve sketching procedure. Curve sketching procedure. What is the procedure here? First what? First, find first and second derivative. That's the first thing. So what is the second thing? Second, what? It's called the what? This is the graphing chart. And then what? Then sketch curve. So we have 3 steps. Of course, the what is it? The second step, the graphing chart. This usually tends to be the most difficult procedure, the step. So in this case, how does this graphing chart look like? This is how the graphing chart looks like. You know what? How about this? X-intercept and this here. What is this? Redo. Let me do this here, eraser. Let me just erase this part here. Okay, so now what I'm going to do is I'm going to create a chart. The chart is going to look like this. 1, 2, 3, 4. It's a chart. It's like a chart with 5 rows, and then we put 1 vertical line here. And this is how the chart looks like. And we are now going to write the chart. Okay, now we are going to complete the chart. This is how the chart is going to be. So what we have is we have what? The annotate, and then I'm going to now graphics. So now here I'm going to put the X here. And then here I'm going to write F. The second row, the third row, I'm going to put F prime. And then I'm going to write F double prime. And then the last row, this is what we call the piece, that piece. Or one of the 4 pieces. The curve piece. The curve piece. Or we don't put any title there, but that basically we'll put in the curve piece. And now what we want to do is on the top row, this is the very important, the easy step, but the important step is to figure out the top row here, the very top row, what do we put it in? So what we put here on the first row, this will be very important. Again, this is a polynomial, so we will always have an infinity here, and minus infinity, unless the domain is restricted. So we will always have infinity and minus infinity. I'll talk more about these guys here. When the domain is not the entire real line, okay? So so for polynomials, this is always what we have. That's the domain. So domain is the entire line. Now, what we put in the first row, what we do put in the first row, we look at the first and the second derivative here, and then look for all the zeros. So we have 0, then we have 2, then we have 4. And so that's it. That wraps up the first row. The first row, what are the points we put? We put the critical points.
Yeah, I'm about to leave.
Critical points.
7.
Critical points.
7.
And what? Critical points and what? And
7.
points. And points.
7.
Or and behavior.
7.
So that's what we put on the first row. So what are the points and the critical points? So what are they? Well, what are the critical points? The critical points are what? What are the critical points? So let's now review what critical points. What are the critical points? The critical points are basically this: f prime is equal to what? Is equal to 0, or f prime does not exist. Does not exist, or it's an endpoint. Endpoint or end behavior. Endpoint or end behavior. End behavior or endpoint. End behavior. End behavior, what I mean by end behavior is infinity or minus infinity. That's basically that's end behavior. And then the endpoint. By the way, the endpoint, even though it's an endpoint, it's not really always the end. I'll talk about that. The endpoint, what is an endpoint? Endpoint? Endpoint is not showing up on the end all the time. I'll give you some examples. But these are endpoints. Okay? Endpoints and end behavior. So these are what we call the first order critical points.
Yes,
And then now
that's
we
how
have
we
what
know
we
it's
call the
taken.
second order critical points. And so we have this critical point f double prime equal to 0 and f double prime does not exist. So these guys right here, let me see. These guys right here, these are what I call the first order critical points. These guys right here are what I call the second order critical points. The critical points really referring to first and second order critical points. The definition you see on the notes on section 3.1, that's what we call first order critical points. But when you construct the chart, you also need second order critical points, which are these two right here. So now for polynomials, the f prime always exists. So this one we don't have it. An endpoint we don't have it. So for polynomials, for poly, what do we have? For poly, we only have two kinds. For polynomial, one of the critical points, we only have this kind right here, where the derivative is 0, and we have this kind right here. F double prime is 0. All the other kinds, we don't have it. So that's why it's easier. So now let's see. Why is this infinity here? Can you figure out why this infinity here? Why is this infinity here? Why is this infinity here? Oh, sorry. Why is this infinity here? Infinity, why is that there? Because it is an end behavior. But you know what? Polynomials, we do have end behavior. We have plus and minus infinity. So we have the end behavior, plus and minus infinity. Wait, you know what? I put the wrong thing. Why did I put minus infinity here? This should be plus, and this should be what? Be minus. So yeah, that's, let me take it back. So this should be, I don't know what we can say. Yeah, there you go. So there you go. You know what? There you go. Should be minus infinity. So so this minus infinity here. See, these are end behavior. End behavior. They are end behavior. End behavior. Now, what is the 0 here doing here? Why is the 0 here? Which condition does 0 satisfy? F prime is 0. Right there. F prime is 0. See? When F prime is 0, when x equals 0 or 4. So 4, same thing. This guy here, F prime is 0. And then, why is the 2 there? 2 is there because the second derivative is 0. F double prime is 0. So every point has a reason. Note that 6 is not there. 6 is an x-intercept. We have the x-intercept 6, 0 here. That is an x-intercept. Together with a 0, 0. So those are the x-intercepts. 0, 0 and 6, 0. However, x-intercepts are not there. The reason why 0 is here is because 0 is the 0 right here. At that point, the derivative is 0. That's why it's there. Not because of the f of x, but because of f prime of x. So these are the points. So x equals 6 doesn't show up here. So now, once we have that, then now what is this here? This is how it's going to look like. F prime is what? F prime is here. F prime is what? 0 here. So put a 0 here and 0 here. Now we have to analyze sign. What happens if x is now bigger than 4? If then it's positive. And when it crosses over the 4, crossover, now x is now 4 is a little bit less than 4, then now this becomes what? This is the first power, we change sign. So when you change sign here, we get a minus here, and we get a minus here. And when it crosses over the 0, then now this x is the first power here, so we change sign, we actually get a plus sign. Does anybody have any question about this? Anybody has a question about the signs of f prime? That is the role for f prime. Do everybody see this? By the way, the plus should be a little bit to the left, to the right, not under infinity. So let me write the plus again. Let me write the plus over here. Sometimes we will write something right below infinity, minus infinity, okay? So this is a plus. Okay, now let's look at f double prime. F double prime is there, and then this is a factor form right here. So now when x is now what happens is when x equals 2, it is actually 0. We put a 0 here. When x is bigger than 2, then f double prime is positive, plus plus. And then when x is less than 2, then f double prime is negative. So we have minus here, minus here. So now the row for f double prime is now complete. Now how about the row for f? When x equals 0, we can plug in, we get a 0. When x equals 2, then plug in 2 there, 2 squared, and then times minus 4, or you get minus 16. And then when x equals 4, then we get 4 squared, 16. 16 times minus 2 is minus 32. And then now here's the question here. When x is approaching infinity, how does the curve look like? The curve is actually going to look like will have the shape of x cubed. So I like to put x cubed here. This shows that this x is heading to infinity at the rate of x cubed. And then infinity here, this one also goes at the rate of x cubed. So we don't write minus infinity plus infinity. This is what we write. That means that when x is heading to minus infinity, it is going to go down to minus infinity at the rate of x cubed. That's how fast it is going down to infinity. So I like to write that x cubed there. So this is roughly x cubed. When x is a very big number, small number, we get this. Now the last row, curve piece. Now from here, look at this. F prime is positive, f prime is positive, and then f double prime is negative. What does that mean? That means f is increasing, concave down. How does the curve look like? Now you have to figure out which part of the 4 piece this is. Is it this piece, or is it that piece, or is it this piece, or is it this piece? So f is what? So in this case, what is this here? F is going to be f prime is positive. That means f is increasing, concave down. Looks like it is this piece. So between when x is less than 0, it's this piece. Now how about when x is between 0 and 2? F prime is negative. That means f is decreasing, concave down. Oh, it's going to be this piece. And then now, when x between 2 and 4, what is that? A minus plus. F is decreasing, and then f double prime is positive, so f is concave up. F is decreasing, concave up. That means it's going to look like this. And then plus plus, that means it is increasing, concave up. It looks like the curve is like this. So now we are ready to actually sketch this. When you go to decimals, of course we can graph it. So this is going to be 0, 2, and 4. And now what we want to do is we actually want to mark the 6 here. So how does the curve look like? A 2, minus 16 right here. And then 4, minus 32 right here. The curve here, and note that at 4, note that the slope is 0 here.
Squeeze the news on, okay?
Come here, sweetie.
And then at 0, it's also 0 here too. And so at 0 and 4, we actually have a horizontal tangent line, so we get this. So let me just do that. Now, what we can do is we now go and curve like this. And this slides down. And then now what happens from 2 to 4, it's going to go like this. And then go like that. Now we have horizontal tangent line here as well. There it goes down like this. Now what? We have a point right here, inflection point. We have a maximum here. This guy is a max. It is a relative max. It is a relative max. And then we have a min here right here. This guy is also a relative min. Relative min. This guy is a relative max. And this guy is also a relative min, if you will. But if you can just write max and min. And if you write max and min, that's good enough. And then here, at this point right here, at 2, negative 16, what is that point? This is now called inflection point, IP. It's not Internet Protocol, it's inflection point in our class. So this is how the chart is. And of course, you have to actually mark these points here when you curve sketch it. Now, class, this is an online class. I'll probably will not be giving you a curve sketching problem, but I will ask you something about the graph. All right, I will ask you something about the graph, so you will kind of know. You have to understand. And by the sum of these things, you will not be able to answer by looking at the graph. If you want to find the inflection point, then you don't know really where the inflection point is.